Elements can become more stable by gaining or losing electrons, and when they do, they form ions, charged particles. In this video, we're going to talk about monatomic ions, one atom that has gained or lost electrons, and the compounds that they make. Metals lose electrons to form cations. So let's look at sodium metal. Sodium has 11 protons, or it wouldn't be sodium. The number of neutrons determines the isotope. And over here, we're not indicating anything because the number of protons and the number of electrons are the same. Protons are positive, electrons are negative, the overall charge is 0. So because we're talking about an atom, protons equals electrons, and there is no net charge. And for that reason, we just leave that space blank. But if sodium were to lose one electron, it would still have 11 protons and some neutrons, depends on the isotope. But if it lost an electron, it would only have a negative 10 charge. And then when we add the pieces together, 11 minus 10, we end up with an overall charge. And that would be reflected here. Sodium still has 11 protons and some neutrons, but now it is an ion. When sodium metal becomes more stable by losing electrons, it always loses one electron. Sodium metal only forms a +1 ion. Nonmetals gain electrons to form ions, and we call those negative ions anions. Fluorine is an example of a nonmetal. As you know, fluorine is one of the 7 diatomic elements. But if we look at just one atom of fluorine, we recognize it has 9 protons, or it wouldn't be fluorine. Some neutrons, depends on the isotope. And overall, there's no charge. And if there's no charge, we just leave that spot blank. But for fluorine to become more stable, it can gain 1 electron. So fluorine, the atom, has 9 protons, each with a +1 charge, so a +9 charge in the nucleus. Some neutrons, we don't know, it depends on the isotope, but neutrons are neutral. And 9 electrons in the atom. And electrons have a negative charge, so there's a -9 charge overall. The overall charge for an atom is 0, and we say it's neutral. But if fluorine were to gain 1 electron, it would still have 9 protons, some neutrons, and gaining an electron, it would now have 10 electrons for a -10 charge. 9 minus 10 is -1. When fluorine becomes fluoride, the ion, it always has a -1 charge. 9 protons, some neutrons, a -1 charge. This is the ion. When sodium becomes sodium ion, we call it sodium ion. So the name really hasn't changed much. We add the word ion. When fluorine or any nonmetal gains electrons to become an anion, the name does change. Fluorine becomes fluoride ion. Fluorine becomes fluoride. So there's a pattern on the periodic table where main group elements gain or lose electrons, and the pattern is this. You'll remember the main group elements are group 1, group 2, and then 3 through 8. So right now we're only talking about main group or representative elements. But every element in group 1 is in group 1 because it behaves in a chemically similar manner. The reason they're in a family is because they have some family characteristics. And one of those characteristics is elements in group 1 lose 1 electron to form cations to become more stable. Why? So that they have the same number of electrons as the most stable elements, the inert or noble gases. Group 2, alkaline earth metals, also behave in a chemically similar manner, but when they form ions, they lose 2 electrons. If magnesium with 12 protons and 12 electrons, so that would be an atom, were to lose 2 electrons, you lose something negative, you become more positive. Magnesium would have 12 protons, some neutrons, and if it loses 2 electrons, it has 10 electrons. And the overall charge is +2. So everything in column 2, beryllium, magnesium, calcium, strontium, barium, and radium, when they become more stable by forming ions, they lose 2 electrons. Metals in group 3 would lose 3 electrons and form +3 ions. Nonmetals gain electrons to form anions. Fluorine and everything in the halogen column becomes a halide, and by gaining 1 electron, has the same number of electrons as the next noble gas. Things in group 6, nonmetals in group 6 would lose 2 electrons. Nonmetals in group 5 would lose 3 electrons. So there's a pattern based on their position, an element's position to the noble gases. Metals lose electrons to have the same number of electrons as a noble gas or be isoelectronic with a noble gas, and nonmetals gain electrons. Ionic compounds form when cations and anions stick together. And they stick together in a ratio that gives no overall charge. Sodium is a +1 metal. Sodium ion is a +1 ion. And fluoride is a -1 ion. And so when they stick together in a 1-to-1 ratio. We don't write the ones, they're implied. But if the number were something besides 1, then we would definitely write it. So here we have a formula for sodium fluoride. We don't need to say anything about the charge or the ratio because we have a periodic table. And based on their position in the periodic table, we know what charges they're going to form. Okay, so barium has a +2 charge and fluoride has a -1 charge. We're going to need 2 fluorides, 2 -1s, to balance out that +2 charge. Aluminum ion. Aluminum is a metal in group 3. Metals lose electrons. How many? It loses 3 electrons. Aluminum has a +3 charge. Fluoride has a -1 charge. We're going to need 3 fluorides to balance that +3 aluminum charge. Okay, so let's look at this place. We have a cation with a +1 charge and an anion with a -2 charge. So we're going to need 2 cations to match the charge of that one anion. So this 2 becomes this subscript. And this is sodium sulfide. Barium is +2 and sulfide is -2, so they come together in a 1-to-1 ratio. Aluminum is +3 and sulfide is -2, so we're going to look for the lowest common multiple between 3 and 2, which is 6. If we have 2 aluminum ions, we have a +6 charge for the cations, and 3 sulfides means a -6 charge, and when we put those together, we get a compound, no net charge. So the formula for aluminum sulfide is this. Sodium nitride, we need 3 sodium ions to balance that -3 nitride charge. Barium nitride, just like aluminum sulfide. We have +2, -3. We're going to shoot for a 6. So if we had 3 bariums, that would be +6. And if we had 2 nitrides, that's -6. And that adds to 0. We formed an ionic compound. Aluminum is +3, nitride is -3. They come together in a 1-to-1 ratio. Whenever we write the formula, we put the cation first. And whenever we write the name, we name the cation first. And basically, we're following the periodic table. What is ever left on the periodic table is going to go first, and whatever's on the right would go second. Okay, transition metals. Transition metals are the not representative elements. These are transition metals, and then right here are the intertransition metals. But in our class, we mostly ignore those. So right now I'm just referring to this region here. Sometimes I call the transition metals the unknown zone because we don't know how many electrons are going to be lost. But metals lose electrons to form cations, so we know that they will make something with a positive charge. So transition metals also lose electrons, but typically have more than one charge possibility. So in our class, we're just going to focus on a few. We're going to say for chromium, iron, and cobalt, the possibilities are +2 or +3. For copper, mercury, for copper and mercury, the charge choices are +1 and +2. So yellow is still +2, and we'll let this peachy color be +1. Okay, so for these, and actually I'm going to keep going, there's going to be 2 more possibilities. For tin and lead, now these are exceptions because they're not in the unknown zone and they're not transition metals, but they do have 2 charge choices that are possible. The first is +2, and the second is +4. Okay, so for transition metals, not just the ones that we've mentioned here and these two exceptions, but all transition metals, there's more than one charge choice possible. And so we have to tell someone which one we're referring to in the name. So here I have copper with a +1 charge, and its name will be copper 1. And I'm writing the 1 in parentheses with a Roman numeral. For iron, the two charge choices are iron 2. So this 2 in Roman numerals in parentheses is referring to that charge. And iron 3. But as far as forming the compounds, the formulas for the compounds, the rules are the same. So copper 1 plus fluoride come together in a 1-to-1 ratio. And we call it copper 1 fluoride. For iron 2 and fluoride, we're now going to need 2 fluorides to balance that +2 charge. And that is iron 2 fluoride. Iron 3 will have a different formula because 3 fluorides are required to balance that +3 charge. And so we need to say it's iron 3 fluoride. If we were just to say iron fluoride, that would be wrong because it's ambiguous. I don't know which one you're referring to, this one or that one. Okay, copper 1 and sulfide, we're going to need 2 copper 1s. So we have a +2 charge to balance that -2 charge. This is copper 1 sulfide. The 1 refers to the charge. Why are there 2 of them here? Because we needed 2 +1s. To have a net +2 charge to balance sulfide's -2 charge to make a compound. Iron 2 sulfide comes together in a 1-to-1 ratio because both charges are 2. Iron 2 and sulfide is -2. For iron 3 sulfide, we're going to need to shoot for the lowest common multiple, which is 6. So I'm going to need 2 iron 3s and 3 sulfides to make a compound. 1, 2, 1, 2, 3. So iron 3 sulfide requires 2 iron 3s and 3 sulfides. Copper 1 nitride, iron 2 nitride, we're going to need 3 iron 2s to have +6 and 2 nitrides to have -6. And then iron 3 nitride comes together in a 1-to-1 ratio because +3 and -3 adds to 0. There are some exceptions, and we've already met 2. We have looked at tin and lead. And we've said, well, there are 2 charge choices. Tin and lead have a +2 form and also a +4 form because somehow that makes them stable. So the reason these are exceptions is because they are main group metals and they have more than one charge choice possible, or we would say they have a variable charge. The other exceptions are exceptions because they don't have a variable charge. They're in the transition metal area, but have fixed charge. As ions, silver can only have a +1 charge. And then zinc and cadmium can only be +2. So we could think about, so these are not exceptions, but they do help us kind of keep track of that. So these are main group metals. We would expect them to have a +3 charge, and they do. But it helps us keep track of the exceptions, because we could say, oh, +1, +2, +3. There's 1 +1. There's 1 +1. There's 2 +2s. There's 3 +3s, and they make nice little stair steps. So the exceptions are these. Silver only forms a +1 ion. Zinc and cadmium only form +2 ions. And tin and lead, main group elements, have 2 charge choices possible, +2 and +4. So when you're going from the name to the formula, or the formula to the name, have your periodic table handy. So here we're going from a formula to a name, and I need to look at this metal and decide, do I need to state the charge? Here's calcium. Nope. Calcium is going to be a +2 ion because it's an alkaline earth metal and it's in group 2. So I don't need to say anything about that. I just name calcium chloride. Here we have copper. We check our periodic table and recognize that copper does have charge choices. The choices are 1 and 2. Which one do we have here? Well, this must be copper 2 because there's 2 -1 chlorides, and it needs to add to 0. So this one is copper 2 chloride. Okay, now we have tin. It would be tempting to say, oh, tin has choices. The choices are 2 and 4. It would be tempting to call that tin 2, but it's not tin 2. And the reason is oxide is in group 6. And if we have 2 oxides, that means we have a -4 charge. So the tin, to balance it, would need to be +4. Tin, 4, oxide. Let's take a look at oxide real quick. So here's oxide. It's in column 6. Oxygen has 8 electrons. To be like the nearest noble gas, it would have to gain 2 electrons. And so 8 protons. Some neutrons, but we don't know. That was an isotope question last chapter. And now, with 2 extra electrons, it has 10 electrons. So when it becomes like neon with 10 electrons, it has a -2 charge. So -2 twice means -4. This must be 10-4. Okay. So here we have silver oxide, but do I need to say which silver oxide? Let me find it on the periodic table. Here's silver. Silver's an exception because the only charge choice for silver is +1. And because it has a fixed charge as an ion, I don't state the charge. This is just silver oxide. Okay, nomenclature is important and it takes a lot of practice. I would probably make a periodic table where I have reminded myself of the exceptions, and I have made a color key to remind me that group 1 forms +1 ions, group 2 forms +2 ions, group 3 +3 ions. And then nonmetals gain electrons. The halogens form -1, group 6 forms -2, and group 3 form -3 ions. I would definitely color or highlight a periodic table and have that handy throughout the rest of the semester. Okay, thank you for your time.